Without a diagram, it's impossible to definitively diagnose the cause of the strobing fluorescent lights when the table saw is turned on. However, we can explore several common causes and troubleshooting steps in a general sense. One potential cause is a voltage drop. When the table saw starts, it draws a significant amount of current. If the wiring in the barn is undersized or if there are loose connections, the voltage can drop substantially when the saw is running. This voltage drop can affect the fluorescent lights, causing them to flicker or strobe. Another possible cause is harmonic distortion. Table saws, especially those with universal motors, can generate harmonic currents that pollute the electrical system. These harmonics can interfere with the operation of electronic ballasts in the fluorescent lights, leading to strobing. A third cause might be related to grounding. An inadequate or improper grounding system can lead to voltage fluctuations and electrical noise that affects sensitive electronic devices like fluorescent lights with electronic ballasts. A shared neutral conductor could also be a culprit. If the table saw and the lights share a neutral conductor, the current drawn by the saw can induce voltage fluctuations on the neutral, affecting the lights. Furthermore, consider the ballast type. Older magnetic ballasts are generally less sensitive to voltage fluctuations than newer electronic ballasts. If the barn has a mix of ballast types, the lights with electronic ballasts might be more susceptible to strobing. Finally, power quality issues from the utility can also play a role. Voltage sags, surges, or other power line disturbances can exacerbate any existing problems in the barn's electrical system. To troubleshoot this issue, a systematic approach is required. Firstly, check the voltage at the outlet where the table saw is plugged in, both with the saw off and while it's running. A significant voltage drop when the saw is running indicates undersized wiring or loose connections. Use a multimeter to measure the voltage. If the voltage drops below 108 volts when the saw starts, it could indicate an issue. Secondly, inspect all wiring connections in the circuit, from the breaker panel to the outlet. Look for loose connections, corroded wires, or signs of overheating. Tighten any loose connections and replace any damaged wiring. Pay special attention to connections in junction boxes and at the breaker panel. Thirdly, verify the grounding system. Ensure that the ground wire is properly connected at the outlet, the breaker panel, and the main service entrance. Use a multimeter to measure the resistance between the ground wire and a known good ground. The resistance should be very low, ideally less than 1 ohm. Fourthly, try plugging the table saw into a different circuit in the barn, preferably one that is on a different breaker and does not share a neutral with the lights. This can help determine if the problem is specific to the circuit where the saw was originally plugged in. Fifthly, consider using a power conditioner or surge protector for the fluorescent lights. These devices can help filter out voltage fluctuations and electrical noise, which may reduce or eliminate the strobing. Sixthly, check the ampacity of the circuit breaker for the table saw and ensure it is properly sized for the saw's motor. Overloading the circuit can cause voltage drops and other problems. If the breaker is tripping frequently, it may need to be replaced with a higher amperage breaker, but only if the wiring is rated for the higher current. Always consult the National Electrical Code, or NEC, and a qualified electrician before making any changes to the electrical system. Seventhly, investigate the type of fluorescent lights installed. If they are older lights with magnetic ballasts, they may be more tolerant of voltage fluctuations than newer lights with electronic ballasts. Try replacing the lights with LED fixtures, which are generally more energy efficient and less susceptible to strobing. Eighthly, evaluate the overall load on the circuit. If the table saw is drawing a large amount of current and other appliances or equipment are also connected to the same circuit, it can overload the circuit and cause voltage drops. Try disconnecting some of the other appliances to see if it reduces the strobing. Ninthly, measure the current draw of the table saw using an amp clamp. This can help determine if the saw is drawing more current than it should be. If the current draw is excessive, it could indicate a problem with the saw's motor or other components. Tenthly, consult with a qualified electrician. If you are not comfortable working with electricity or if you have tried the above steps and the problem persists, it is best to call a licensed electrician. They can perform a more thorough inspection of the electrical system and identify any underlying problems. Here are some additional points to consider. Check the voltage rating of the fluorescent lights. Make sure they are rated for the voltage being supplied in the barn. If the lights are not rated for the voltage, they may be more susceptible to strobing. Examine the wiring gauge used for the circuit. Undersized wiring can cause voltage drops and other problems. The wiring gauge should be appropriate for the amperage of the circuit and the distance from the breaker panel to the outlet. Consider the age of the electrical system. Older electrical systems may have deteriorated wiring and components, which can contribute to electrical problems. If the electrical system is very old, it may be necessary to upgrade it to meet current safety standards. Be aware of potential safety hazards when working with electricity. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate safety gear. If you are not comfortable working with electricity, it is best to call a qualified electrician. The NEC, specifically Article 220, covers branch circuit, feeder, and service calculations. Article 300 covers wiring methods and materials, and Article 310 covers conductors for general wiring. These articles provide guidance on selecting the appropriate wiring size, overcurrent protection, and other electrical components. For example, NEC Table 310.15b16 provides opacity ratings for conductors based on their size and insulation type. This table can be used to determine the appropriate wiring gauge for a given circuit. Understanding the NEC and following its guidelines is essential for ensuring the safety and reliability of electrical systems. Another potential issue is loose neutral connections. This can cause erratic voltage fluctuations and can be particularly problematic for electronic devices. Check the neutral connections at the breaker panel, the outlets, and any junction boxes. Make sure they are tight and secure. If you find any loose connections, tighten them carefully. Another factor to consider is the type of motor in the table saw. Induction motors and universal motors behave differently under load. Universal motors, commonly found in cheaper tools, tend to draw more current on startup and can cause more significant voltage dips. If the table saw has a universal motor, this could be contributing to the problem. In some cases, installing a dedicated circuit for the table saw can help to isolate it from other sensitive equipment. This involves running a new circuit from the breaker panel to a dedicated outlet for the saw. This can help to reduce voltage drops and electrical noise on other circuits. When inspecting the wiring, look for any signs of damage or deterioration. This includes cracked insulation, corroded wires, and loose connections. Any damaged wiring should be replaced immediately. It's also a good idea to check the condition of the circuit breaker. Over time, circuit breakers can wear out and become less effective at protecting against overloads and short circuits. If the breaker is tripping frequently or if it appears to be damaged, it should be replaced. Remember to always follow safe electrical practices when working on electrical systems. This includes turning off the power to the circuit before working on any components, using insulated tools, and wearing appropriate safety gear. If you are not comfortable working with electricity, it's best to call a qualified electrician. Power quality can also be affected by external factors, such as nearby industrial equipment or utility grid issues. If you suspect that the problem is related to external factors, you can contact your local utility company to request a power quality analysis. They can monitor the voltage and current on your service and identify any potential problems. Another troubleshooting step is to use a circuit analyzer. This is a device that can measure various electrical parameters such as voltage, current, power factor, and harmonic distortion. By connecting a circuit analyzer to the outlet where the table saw is plugged in, you can get a detailed picture of the electrical conditions and identify any potential problems. Harmonic distortion can be mitigated by using harmonic filters. These are devices that are designed to reduce the level of harmonic currents in the electrical system. They can be installed at the breaker panel or at individual loads, such as the table saw. Power factor correction can also help to improve the efficiency of the electrical system and reduce voltage drops. This involves adding capacitors to the circuit to compensate for the inductive reactance of the motor in the table saw. In addition to checking the wiring and connections, it's also important to inspect the condition of the electrical panel. Make sure that the panel is properly grounded and that all of the breakers are securely mounted. Look for any signs of damage or corrosion. If the panel is old or in poor condition, it may need to be replaced. Furthermore, NEC Section 250.24 covers grounding requirements for separately derived systems. Section 300.3 covers the requirements for parallel conductors, and Section 314.16 covers the number of conductors allowed in outlet, device, and junction boxes. The goal is to determine if a voltage drop may be the cause of the lights to flicker. It is not uncommon for undersized conductors to cause this effect, but the correct wiring and connections will help to solve the issue. If you were to measure the voltage at the source and the load, there is a good chance it will show a difference, which can be considered a voltage drop.